All right, welcome back to part 4, where we'll be doing something mind-blowing yet again. In this part, we will be connecting ChatGPT to a database and then using ChatGPT to extract information from the database using only natural language on the end user's part. This is a very powerful tool that can be used to create a chatbot that can answer questions about information in an in-company database that is not available to the outside public. As with each part, we have some additional setup work to do. We will be creating a database utility, a prompt setup message to feed to ChatGPT, and of course a function description to explain to ChatGPT how our database function we will feed it works. If you don't know SQL, don't worry, ChatGPT will be generating the database queries for us. SQL is a fascinating and fun subject all on its own, but we'll not go off on that particular path for this tutorial series. Again, ChatGPT will generate the queries for us, so if you're not too familiar with SQL, don't worry about it for now. Let's just get started. So, in your utils folder, first create this new file called database.py, which we'll use for a database utility. So we'll first create a class called database, which we'll just use as a quick container for some of our utility functions we'll be using. Let's first initialize our class and then declare our methods inside. So the class database takes a database connection as an argument, after which we set self.connection to the connection. This will allow us to use the connection in our methods. And we'll get to the first method. The first method we'll create is getTableNames. This method will return a list of all the table names in our database. We do this by first creating an empty list called TableNames. Then we create a query that will return all the table names in our database. Note that the query is quite readable even if you don't know SQL. We select all the names from the SQLite schema where the type equals table. So we just select all the names from anything that has the type of table. We then execute the query using the execute method, which we'll create later. So it's calling self.execute, which does not exist yet, but we'll create it in a moment, so don't worry about it. We then loop through the results and append the first item in each result to our table names list. The 0 index will have the actual name of the table. So for each table in this result, we'll append the index 0 to this empty list, which will then hold only our table names, which we return. The second method we'll create is getColumnNames. This method will return a list of all the column names in a given table. We do this by first creating an empty list called column-names. We then create a query that will return all the column names in a given table. This query looks a bit more cryptic, but basically the pragma table info method will allow us to get metadata about the columns in a specific table. Again, we won't go too deep into SQL in this tutorial. We then execute the query using the self.execute method. Again, we'll declare it in just a moment. It doesn't exist yet. And we then loop through the results and append the second item, or index 1 in this case, to our column names, because this is the particular item that has the column name. Then we return this list with all the column names in that particular table. The next method we'll create is getDatabaseInfo. This method will return a list of dictionaries containing the table names and column names for each table in our database, using the two methods we already created above. So we create an empty list database info for each table name in self.getTableNames, which we just defined. It will get the column names by calling self.getColumnNames on this particular table name, and then it will append a dictionary containing the table name info and then the column names for each table. And then we simply return this database info. So the next method we'll create is execute. This method will execute a given query and return the results. We do this by first executing the query using self.con.execute with the query passed in, and then returning the results using res.fetchAll. And the last method we'll create is close, which simply closes the database connection. The full database utility class now looks like this. We have already in it then the get table names, get column names, get database info, which runs both of these, the execute function and the close function. Again, if you're less familiar with SQL, don't worry about it. We won't be doing too much SQL in this tutorial, as ChatGPT will be doing this for us. So let's prepare our prompt setup for the database querying ChatGPT bot next. In your prompt setups folder, create a new file called database.py, and inside we'll just declare a simple variable with a basic setup explaining ChatGPT what its new identity is. You are an in-company Amazon bot providing information on customer review helpfulness data. We'll get this database in a moment. It's a freely downloadable database. You answer the user's query in the most helpful way possible using the database and function provided. Provide plenty of information. So we can just go ahead and save this and close it. Now, I've based this setup message on a freely available SQL database. The database contains information about customer reviews on Amazon for us to play around with. So go to this link, and it's a little bit long, so apologies for that. kaggle.com/datasets/joy Chakraborty 2000/Amazon customers data. And if you go here, you can just click the download link. You'll probably need to log in using your Google account, or you can just create a quick account to get to the download. But it's completely free, so don't worry about it. You can also just, I like to just use my Google account because it's quick. You just have to click once and you're done. And when you download the file, unzip it and place the database.sqlite file inside your base directory. So inside the zip file, there will be two files. One is a reviews.csv and one is a database.sqlite file. You can ignore the reviews.csv file for now and just place the database.sqlite file in your base directory like this. You can open up this database using SQLite browser or similar software, but you can also just look around on my screen. I'll open it up for us. And just make sure this file is in your tutorial base directory and you'll be fine. And I'll go ahead and describe the base structure of this database so you have an idea. But of course, if you're curious, you can also open this up yourself. The idea is just a database ID. The product ID is just some kind of generated ID for this particular product, so we can have multiple reviews for the same product, as you can see here. Some cryptic ID of the user who wrote the review. We have the profile name of the user who wrote the review. The helpfulness numerator is the number of helpful votes this review has received. So 4 people have voted that this review was helpful. The helpfulness denominator is the total number of helpful or unhelpful votes this review has received. So in this case, 4 people voted on this review and all 4 of them voted that it was helpful. But in this case, 5 people voted on this review and only 4 thought it was helpful. So 1 thought it was unhelpful, I guess. The score is whatever score the user gave this product that they bought. So this, my cats are not fan of this. This is a 1-star review, and great, this is a 5-star review. So he was very happy. Then we just have a timestamp. We have the summary of the review and then the complete text. It's a little bit cut off here. I'll just enlarge this, but this is the actual review the user wrote. So yeah, that's the basic database. Just make sure you save it here. You don't have to open it up yourself. We'll just use ChatGPT to answer our questions for us because hey, why not? So next up is our function description that we feed to ChatGPT to let it know what our function does and what arguments it needs to be called. In your function descriptions folder, create this new file named database.py. Now inside this file, let's define our function description, and it will be quite a bit longer than the previous ones. This function description is quite a bit more complex than the ones we've created before. This is because I've provided ChatGPT with some hints about the database structure to help it perform optimally. You can see I've specifically cleared up some confusion about the column namings to be very clear about what the meaning of the profile name, helpfulness numerator, and helpfulness denominator columns is exactly and what they mean. This sort of setup comes about by just playing around and seeing where ChatGPT has problems and then providing it with more information to help it out. As some of the column names in the datum set were kind of weird, I've simply provided descriptions on exactly what they were. So we actually have the name get info from database, description, use this function to answer questions about Amazon customer reviews and their helpfulness. If the user asks for a customer's name, this will refer to their profile name specifically. The helpfulness numerator is the number of helpful votes the review has received, where the helpfulness denominator is the total number of helpful or unhelpful votes the review has received. The score column indicates the rating between 1 and 5 the user gave the product in their review. You are not to use the user ID column in your queries. Use the profile name as identifier instead. The argument should be a fully formed SQL query. Now, the parameters here are very interesting. We've seen this part defining the arguments that ChatGPT has to provide several times before, but this time we ask it to provide an argument which has to be a fully formed SQL query. You'll notice this function description is not a variable like the previous ones, but a function which takes an argument of schema and returns the description. So we actually don't have a variable here, but we defined a function which takes a schema and then it just returns this whole text. But we get to pass the schema text in here. So we can ask for a query as a parameter, which has to be of type string. And our description of this parameter we require to call the function is an SQL query extracting info from the database to answer the user's question. The database schema is as follows, and we can pass in the schema because we made this into a function, returning the text, passing in the schema here. And then the query should be returned in string format as a single command. So we're just saying, hey, ChatGPT, you need to provide us with a query which is required, and it has to be a fully formed SQL query. Then we can just go and take this query and execute it on our database and we'll get the information. So yeah, that in theory sounds really good, but in practice it actually works pretty darn well. You'll be impressed. And of course, before I forget to mention, the whole reason we made this utils database, this whole get database info with the column names and the table names, is so we can run this and it will get all the table and column names in this database. And then we can pass this schema in here, which will actually pass the whole schema in the function description. and that will give ChatGPT all the column and table names, the table and column names in here, so that it has the required information it needs to query our database and answer a question. So that's why we made this whole thing here. Okay, so now that we have our database utility class, prompt setup, function description, and database file all ready, it's time to have some fun here. Create a file in the base directory called da databasefunctions.py. And again, we'll start with our imports up top. We'll be using the JSON library again for the dump to string function, and SQLite3 for the database connection. All the rest are our own files we've created in the previous parts, so we're just importing our own helper functions. Now first we establish a connection to the database. Make sure both files are in your base directory. So I have my database functions.py and our database.sqlite in the same directory. Otherwise you have to, of course, change this path. Then we just have a print database connection was successful. We create a new database utils class instance, passing in our connection, and we name this company database. So this is a database utils class for the utility we just made, but we've connected it to this database. And then we get the database schema, which is a variable of type string, but again, you can just leave this out as well. It will work just the same. And this is the get database info. So we're running our own utility get database info from the class and converting it to a string because, again, ChatGPT needs strings. Next, we'll create a quick helper function we'll actually use for the calls. This function will take a query as argument and then execute it using our company database object and then return the results in string format as ChatGPT handles strings. So we use the dump string to get a string from the dictionary. This is of course wrapped in a try except block. So if there is an exception, we just raise exception, error executing query, please try again, passing in a valid SQL query in string format as only argument. From here on, most of the following code should be quite familiar. So I'm just going to paste it in all at once and we'll go over this step by step. So our function takes in the query as argument. We then create a messages list containing the database query bot setup, prompt setup, and the query the user asked. We then create a functions list containing the function description we created earlier. Remember that this time our function description was actually a function, so we pass in the database schema we got above, so we can execute this function and return the actual function description with the database schema embedded inside. So ChatGPT knows exactly how our queries should be written because it knows the exact structure of our database. We then call our own GPT 3.5 Turbo 0613 helper function, passing in the messages and functions list. But this time we also specify a function call, calling our function by name. This means that we'll force ChatGPT to make a function call using this specific function for now. We want it to call function at all times. Then we get the current response and append its message to the messages history as we've always done. Next, we check if the current message has a function call in it. It always should, as we sort of force it. We then specify the available functions. Again, we get the function name that GPT wants to call. Then we get the reference to the real function. We get the arguments, and then we call it, passing in the arguments to get the response. And again, if you're only ever going to use one function, you can simplify this and just call your one function directly, I guess. But we're specifically writing this in a way that we can expand this in the future, and we can have multiple slightly different functions for different purposes and just plug them all in here and give ChatGPT the option to call multiple functions or different functions. Then we append the function's response to the messages. We get the next response calling in our function's return to ChatGPT. We get the current message again and append it. And I made a small mistake here. This should, of course, be outside the if block. When it finishes running, we print our messages and then return the current response. Good, so let's ask some questions. Let's see if this works. So add a print statement to the bottom of the file for a quick test, and I'm just going to ask what is the name of the user who wrote the largest number of helpful reviews. Now let's run this. Database connection successful. Okay. Then it gets the system message or setup. What's the name of the user who wrote the largest number of helpful reviews? We have get info from database, query, select profile name count as helpful count from reviews where helpfulness numerator. Okay, we won't get into the SQL query here because I said we're not going into SQL. But it comes up with this answer. The name of the user who wrote the largest number of helpful reviews is O. Brown, Mrs. O'Cana Brown. This user has written a total of 364 helpful reviews. So that's pretty insane, right? We just ask a natural language question and we get a natural language response. Just giving ChatGPT a random database and just saying, go ahead and query it. I mean, this is insane, pretty much. That's pretty damn cool. So let's try asking some more questions. And I'm going to ask, what is the name of the user who got the greatest number of helpful votes over all their reviews combined? So yeah, we just called the function using the SQL query that ChatGPT defined for us. And again, the user who received the greatest number of helpful votes over all their reviews combined is the Trong Duke of New Mexico. They have received a total of 5,594 helpful votes. So, wow. And I'm going to ask something a little bit more expansive. I'm going to try this next question. Let's see how it does. What are the names of the 10 users who wrote the most reviews? Let's see. Okay, just give it a second to run. Oh, the names of the 10 users who wrote the most reviews are, and we get a neat organized list. So yeah, this is pretty insane. ChatGPT is just generating a query for us. We're just running it without any problem. We don't get any errors in the query. It's actually just a fully formed SQL query that we can just run, get the answer, and ChatGPT even converts it to a natural language response for us. This is feeling pretty artificial intelligence, as in almost an intelligent being. I mean, this is crazy, right? So yeah, that's the end of part 4. I'll see you in part 5, where we'll actually look at calling non-existent functions, which may sound weird, but there's a use for it. And we'll look at some retrying and troubleshooting issues that might come up. So I'll see you soon in the next part.